So imagine sitting in your own home, suddenly arrested, charged with this major crime, and then sentenced to nearly 2 years in prison. And the core evidence against you, like the whole basis of the case, a few isolated retweets on an account that had, I think, fewer than 100 followers.
Right. Yeah.
I mean, we're talking about posts that received 0 likes, 0 comments, and 0 forwards. So you're probably wondering how anyone could possibly defend themselves against that kind of logic, right? Well, today, we're looking at a scholar who took a completely unprecedented approach to his defense.
It really sounds like a surreal thought experiment, doesn't it? But this is a very real legal case from our stack of sources today. And the way the defense was constructed is, I mean, it's unlike anything you have probably ever heard in a courtroom.
Well, absolutely. So our mission for you on this deep dive is to explore the case of Dr. Chen-Jing Wan. He's a scholar with a PhD in physics and complex systems. And when Chinese authorities charged him with picking quarrels and provoking trouble, alleging that his zero engagement retweets caused severe public disorder, he didn't just, rely on standard freedom of speech arguments.
No, he didn't at all. He actually used hardcore statistical physics.
Right. Thermodynamics, quantum mechanics, the works. He used all of that to prove that the prosecution's claims were just mathematically and physically impossible. So we're going to explore how he translated the immutable laws of the universe, things like the fluctuation-dissipation theorem and general relativity, into a literal criminal defense.
And what this teaches you about how information actually spreads in a complex world.
Exactly. Okay, let's unpack this.
Well, before we get into the heavy physics, let's just quickly establish the baseline facts from the legal documents we have. So Dr. Chen was sentenced to 20 months in prison in Kunming. The prosecution's core argument was that his isolated retweets of foreign articles, this included like posts from the U.S. Embassy, actively caused severe confusion of public order.
And just to be super clear up front, we are examining this strictly from a structural scientific perspective today.
Yes, exactly.
We're looking at the logic of a physicist defending himself using the laws of nature. So we're setting aside the specific political viewpoints of either side here to just focus entirely on the mechanics of his argument.
Right, because the foundation of Dr. Chen's defense is really that the prosecution committed this massive logical fallacy. He accused them of a total scale mismatch.
A scale mismatch. Meaning what exactly?
Meaning they were equating a microscopic fluctuation with a macroscopic phase transition. And I know those are heavy physics terms, but they actually map perfectly onto everyday life.
Yeah, they do. So let's break that down. A fluctuation versus a phase transition.
Right. So in statistical physics, any system with a massive number of moving parts, what we call degrees of freedom, is never perfectly still. Think of, the air molecules bouncing around in the room you're sitting in right now.
Sure.
Or the endless flow of data across a social network with hundreds of millions of users. There is a constant underlying hum of random background noise.
And those microscopic variations, those little bumps, are called fluctuations.
Exactly. They are just the baseline state of existence.
Yeah.
So a retweet with 0 engagement from an account with barely any followers is simply a tiny localized fluctuation.
Okay, I follow that. And the prosecution tried to argue that this tiny microscopic fluctuation caused a phase transition. And I mean, whenever I hear phase transition, I always think of water boiling into steam.
That's the classic example.
You're right. It's a complete system-wide shift in the state of matter. Or, I guess in sociological terms, a society falling into severe public disorder. That would be the phase transition.
Precisely. A phase transition requires a fundamental reorganization of the system's entire structure. But in physics, a phase transition never happens simply because of one random fluctuation. A macroscopic shift only occurs when the system's control parameters reach a critical threshold.
Control parameters.
Yeah, so in thermodynamics, a control parameter is something like the overall temperature or the pressure of the room.
Right, meaning you can't boil a pot of water by just relying on the random energy of a single water molecule bouncing around. You actually have to turn on the stove. The stove is the control parameter in that scenario.
You hit the nail on the head there. So in a social network, those control parameters would be systemic forces. Things like algorithmic amplification or massive injections of attention from superhub accounts or, deep underlying societal tensions.
So unless those system-wide control parameters are pushed to a literal tipping point, a single fluctuation just gets instantly absorbed. So wait, let's take that fan analogy a step further, because this is how I was thinking about it. It's like if I wave a paper fan in my living room and the temperature gauge on the wall bumps up by like a fraction of a degree, the prosecution is essentially blaming my paper fan for causing global warming.
That is the exact mathematical equivalent of the prosecution's argument.
Yes.
They are ignoring the stove, the broader societal and algorithmic forces, and they are blaming the microscopic bounce of a single molecule for the entire pot boiling over.
Wow. That is just a staggering way to frame a legal argument. You're basically demanding that the law adheres strictly to the physical boundaries of reality.
Right, you can't legislate away the laws of physics.
Exactly. But I'm curious about how a system naturally absorbs all these tiny bumps without collapsing, because, I mean, we are constantly bombarded by millions of tweets and posts every single second. Why doesn't the system just break down constantly from all that noise?
Well, the mechanism at play there is called the Fluctuation-Dissipation Theorem, or FDT. It's this absolute cornerstone of non-equilibrium statistical physics. It was originally formulated by scientists like Nyquist, Callan, and Welton.
Okay, and what does it actually say?
The theorem states that a system's ability to respond to an outside push, its dissipation or response, is entirely determined by its own internal background noise, its spontaneous fluctuation.
I think we need to break down how that actually works in practice, because it sounds a bit dense.
Here, think of Brownian motion. Have you heard of that?
Rings a bell from high school chemistry, maybe.
Yeah, so if you have a tiny grain of pollen floating in water, it jiggles around constantly, and that's because water molecules are randomly crashing into it all the time. That's the internal fluctuation.
Got it.
If you then apply a tiny external force, maybe you try to push the pollen with a microscopic needle, the way that pollen resists and responds to your push is dictated by that exact same water molecule environment.
Oh, I see.
The system's temperament isn't created by the outside force. It's entirely dictated by the system's own internal structure and friction.
Okay, here's where it gets really interesting based on the sources we read. If I take a cup of warm water and I pour it into the Pacific Ocean, that's a microscopic fluctuation. But the ocean has a massive heat capacity.
Massive.
Right, it has an immense ability to absorb and dissipate that tiny amount of heat without changing its overall temperature. I cannot be arrested for causing a tsunami just because I poured a cup of warm water into the sea. The ocean just swallows it whole.
That translates the legal argument perfectly. Dr. Chen's retweet was the cup of warm water. The Chinese internet, with its massive daily active user base, is the Pacific Ocean.
Yeah.
Because his account had fewer than 100 followers and the post had literally 0 interactions, the signal-to-noise ratio was virtually non-existent. The push he gave the system was infinitesimally small.
And because the internet has that massive heat capacity, meaning, people are endlessly scrolling, they're posting millions of other things, and the platform's algorithms are naturally burying low engagement posts, the network's natural friction just absorbed his post completely.
Exactly. The perturbation was instantly dissipated. Therefore, the causal link required by criminal law, the concrete proof that his specific action caused a macro-level result, is mathematically broken. You just cannot draw a straight line from a single drop of water to a shifting tide.
I am struggling with the ocean analogy a little bit, though.
Oh.
Because we've all heard the butterfly effect, right? Like in chaotic systems. A butterfly flaps its wings in Brazil and sets off a cascade that causes a tornado in Texas.
Right, the classic chaos theory example.
Yeah, so could the prosecution argue that Dr. Chen was the butterfly? Maybe his tiny drop theoretically triggered a massive unseen chain reaction.
It's a very common counter-argument, actually, and the defense anticipated it and used the source material to dismantle it completely. The butterfly effect is widely misunderstood in popular culture. A tiny perturbation only causes a massive cascade if the system is already in a state of what physicists call self-organized criticality, or SOC.
So the system has to be fragile to begin with.
Incredibly fragile. Imagine a bridge engineered to hold exactly 100 tons of weight. Right now, there are trucks parked all over it, and the total weight on the concrete is 99.999 tons.
Okay, so it's right at the limit.
Exactly. The bridge is groaning. Then, a tiny sparrow lands on the railing. That sparrow is the microscopic fluctuation. The bridge suddenly collapses. Did the sparrow cause the bridge to collapse?
Well, the sparrow was the trigger, but obviously the bridge was doomed anyway. The trucks are the real problem there.
Right. In statistical physics, the system itself is the cause of the collapse, because it was already pushed to the absolute critical limit. If the prosecution wants to invoke the butterfly effect, They must first prove that the entire Chinese internet, or society at large, was already in a highly unstable, supercritical state.
Oh, wow.
They would have to legally prove that society was a bridge already carrying 99.999 tons of tension.
Which would require the prosecution to argue that their own society is on the verge of total collapse, which is a political admission they would never, ever want to make.
Exactly. If the system is far away from that critical point, say the bridge only has 10 tons of weight on it, you could land 1 million sparrows on it, and the concrete won't even register the change. The microfluctuation decays instantly.
Makes total sense.
But the defense didn't stop at criticality. They also brought in network topology.
Topology being the physical or, I guess, logical structure of the network itself. And our sources use this brilliant analogy about a snapped guitar string here. Dr. Chen's account was an edge node, meaning he was on the absolute fringes of the network map, with very few connections pointing outward.
Right. In network science, a microscopic disturbance cannot cross spatial gaps if there is no conduction medium. If you physically cut a guitar string in half, you can pluck the left side as hard as you want.
But the vibration will never cross the gap to reach the right side to produce a sound.
Exactly. The physical pathway simply does not exist. Because Dr. Chen had no followers engaging with his post, he had no conduction medium.
He plucked a snap string. His post just never reached the main network.
And the defense quantified this using something called the Cohen critical threshold formula. To put it simply, think of it like the R0 value in epidemiology, which measures how a virus spreads.
Oh yeah, we all learned about that a few years ago.
Right. If a virus has an R0 of less than 1 meaning, each sick person infects fewer than one other person on average, the outbreak is mathematically guaranteed to die out.
It just can't sustain a chain reaction.
The exact same math applies to information networks. This is called the branching ratio. The defense showed that for an isolated edge node like Dr. Chen, the branching ratio of his information was far less than 1. The information cascade dies almost instantly. It is a mathematical certainty. The wave doesn't even make it out of his immediate vicinity.
This shared concept of friction and resistance across completely different mediums is so fascinating. And to make sure that judges truly understood the absurdity of the causal link, Dr. Tim's defense didn't just stick to thermodynamics and network graphs. They brought in an entire arsenal of hard science analogies.
They really did.
Just to prove that attributing macrosystemic collapse to a microfluctuation violates the laws of literally any mature science.
Let's walk through those analogies, actually, because they highlight how universal this concept is. Take electromagnetism. Blaming Dr. Chen's retweet for national public disorder is like claiming that the tiny static shock from rubbing a balloon inside a Faraday cage caused a national power grid failure.
Right, because a Faraday cage completely blocks all electromagnetic fields from escaping.
Exactly. And beyond just the cage, the defense cited the mechanism of Dobie screening. Imagine you drop a single positively charged particle into a massive saltwater solution. Instantly, a cloud of negatively charged ions rushes in to surround it.
Oh, so they just swarm it.
Yes, they completely neutralize its electrical influence over a microscopic distance. The charge is screened out. Dr. Chen's post was immediately screened out by the massive neutralizing friction of the internet.
Okay, and then they apply the exact same logic to fluid dynamics. Claiming a zero engagement retweet caused severe disorder is like claiming a single drop of water falling into a stagnant dead-end pipe somehow caused a massive turbulent whirlpool in a main river channel miles away.
And the mechanism that proves that impossible is the Reynolds number, which predicts whether fluid flow will be smooth or turbulent. It compares the momentum pushing the fluid forward against the viscous friction holding it back.
Okay.
In a dead-end pipe, viscosity dominates entirely. The drop of water hits, the friction absorbs its momentum instantly, and the flow stops. It physically cannot generate the inertial force required to create turbulence.
And they didn't stop at fluids or electricity.
Yeah.
They scaled it all the way up to astrophysics and general relativity.
Yeah, this part is wild.
They said it's like claiming a single grain of sand altered the gravitational structure of the entire Milky Way galaxy. But the most profound analogy was the black hole. They argued it's like claiming a particle falling into a black hole caused a supernova outside the event horizon.
I want to spend a moment on that one, actually, because it illustrates topological trapping perfectly. In astrophysics, the event horizon of a black hole is a point of no return. It defines a causal light cone where all future paths point inward.
So nothing escapes.
Right. Information can go in, but it is causally disconnected from the universe outside. Because Dr. Chen's account had no engagement and no outward reach, it was topologically trapped. It existed inside an informational event horizon.
So attributing real-world macro effects to his retweet violates the most basic laws of causality. It's literally like trying to get a signal out of a black hole.
Precisely. And finally, they looked at nuclear physics. Blaming the retweet is like claiming a single isolated uranium atom triggered a catastrophic nuclear explosion, completely ignoring the absolute necessity of achieving critical mass.
Because if one atom splits on its own, it just sends off a few neutrons that harmlessly bump into empty space and stop. Nothing happens.
Right. To get a nuclear explosion, you need a critical density of uranium so that those neutrons hit other atoms, splitting them and creating an exponential chain reaction. Without that critical mass, the initial split is just a meaningless POC. And what's fascinating here is that these aren't just colorful metaphors designed to entertain a judge. In mathematics, we call these isomorphisms.
Isomorphisms, meaning the underlying structures of these completely different fields map perfectly onto each other.
Yes. The equation that governs the decay of a static charge in salt water is structurally identical to the equation that governs the dampening of a fluid wave, which is identical to the extinction of a nuclear chain reaction without critical mass.
Why?
And all of them are identical to the math governing information decay on a social network. They all prove the exact same physical reality. Macro consequences require macro causes.
So we've gone from a person sitting in their living room, retweeting an article, all the way to general relativity, Debbie screening, and the fluctuation-dissipation theorem. We've seen how a physicist, facing a highly subjective and vague legal charge like picking quarrels, just totally refused to play the game on subjective terms.
He really did. He stripped away the rhetoric entirely.
Right. He demanded that the law adhere to the strict, objective, verifiable boundaries of the physical universe.
If you were going to charge someone with causing a massive systemic effect, you must prove the physical mechanism of that cause. Whether it's the mechanics of phase transitions, network topology, or fluid dynamics, the laws of physics dictate reality. Unless a system is already pushed to the absolute brink, microscopic noise cannot destroy it.
So what does this all mean? Why does this matter to you listening right now outside of a courtroom in Kunming? Because you are constantly diagnosing causality in your own life. The next time you're analyzing a failure, whether it's a project crashing at work, or a sudden shift in team morale, or even a massive internet outrage cycle, don't just look for the last person who touched it.
Yeah, don't just blame the sparrow that landed on the bridge.
Exactly. Look at the system's underlying temperature. Look at the baseline noise. Look at the structure of the network itself.
If we connect this to the bigger picture, it forces us to ask very uncomfortable questions about the environments we operate in every day. It's incredibly easy to point a finger at a microfluctuation. It is much harder to look in the mirror and admit that the system you designed is inherently unstable and lacking the capacity to absorb normal friction.
Which leaves us with a final, lingering thought for you to explore on your own. We've established today that a macro-level collapse can only be triggered by a microscopic event when the system itself is pushed to a highly unstable critical state. So, in our modern world of algorithmic echo chambers, AI-driven feeds, and engagement farming platforms, who is the one actually turning up the temperature?
That's the real question.
If the platform's algorithm is the control parameter that pushes our entire digital society to the brink of a phase transition, making it so fragile that a single post could theoretically set it off, should the algorithm itself be the one on trial?